Now today's topic is tests on transformer. Means we are going to testing the transformer. First we have to know what is the purpose of testing. The purpose of testing is to know the the performance of any machine or device. Performance we can define with two parameters. Those are already discussed. Those are voltage regulation and efficiency. Here regulating parameter is voltage. That's why voltage regulation we have to determine or we have to predetermine, and efficiency when we have to determine and when we have to predetermine our estimation. Determination is direct by putting load. Predetermination or estimation is without putting load. Without putting load we have to estimate the performance of any machine or any device. Now the basic tests are of two types on any device, any machine. Those are direct test or load test. In some machines we can call it as a brake test, and indirect test or no load test without putting load. Welcome to direct test. Here by putting load we can determine efficiency and voltage regulation. We will calculate here, and these tests are used for low rated machines. Why? Because if you run the machine to test on high rated machines, unnecessary electricity bill, wastage of power first of all. So why to waste power? So without wasting power we are testing high rated machine with indirect test. So direct test, load test is used to calculate efficiency or determine the performance of a machine by putting load. And already I explained the tests are of performance parameters are of two types: voltage regulation and efficiency. Now we know the definition for efficiency. Already discussed. Efficiency is nothing but it is the ratio of output power to the input power. It is the ratio of output power to the input power. This formula we use to determine efficiency in direct load test. Similarly, voltage regulation, change in voltage from no load to full load with respect to no load is called voltage regulation. Generally voltage regulation we can calculate from secondary side. Why? Because we are connecting load there at secondary terminals. That's why voltage regulation we define in terms of secondary side only. Now we come to indirect test. We will calculate efficiency by knowing losses, by knowing input power or output power. If you know output power and losses, efficiency formula is output power by output power minus losses. And if you know input power and losses, we will calculate efficiency by using formula as input power minus losses by input power. So indirect test means we won't put any load, circuit is opened. That's why sometimes this example for indirect test is open circuit test also, no load test. Here the main purpose of test is to determine the losses, to estimate the losses in any machine. Indirect test, as we discussed, is applicable for high rated machines without putting load. Right. There voltage regulation from indirect test of transformers we will calculate by using formula as I2 R02 cos phi 2 plus or minus I2 X02 sin phi 2 by E2 secondary side. Primary side if you want, so also you can calculate I1 R01 cos phi 1 plus or minus I1 X01 sin phi 1 divided by E1 there. E1, sorry, not E1, V1 there, V1. Primary side, but majority cases we have to calculate secondary side. Why? Because we are putting load there only. Now come to direct test. So there in the formula voltage regulation, plus is used for lagging loads and minus is used for leading loads. Indirect test efficiency we will calculate by using formula as we discussed, output power by input power. In transformer, output power is V2 I2 cos phi 2, input power is V1 I1 cos phi 1. From indirect test we won't calculate losses, not possible to calculate the losses. At voltage regulation, we will calculate by using formulas E2 minus V2 by E2 secondary side. In case of primary side, V1 minus E1 by V1 means we will get all the values directly. Now come to types of test in transformers. In our syllabus, we are having tests are open circuit and short circuit test is example for indirect test. Second one is direct load test by putting load. And another is sumner test or back to back test. This also comes under indirect test. I mean there also we are not putting any load. Come to open circuit and short circuit test. First, what is the purpose of open circuit test? We'll discuss here two tests separately because each test purpose is different. So first come to open circuit test. Here the purpose of open circuit test is to calculate no load losses or iron losses. To calculate no load losses or iron losses. Second is to estimate power factor. No load power factor. No load power because we are not putting load. And third is to estimate no load branch or shunt branch or parallel branch parameters like R0, X0, IM and IW. No load branch parameters. These we can estimate or calculate from open circuit test. మీరు ఎక్కడ కూర్చుంటారు? తీసుకెద్దు కదా, ఎక్కడ కూర్చుంటే అక్కడ టీవీ ఆఫ్ చేయండి. The purpose of open circuit test. Open circuit test is conducted at low voltage winding side. Open circuit test is conducted low voltage winding side. Why? Because the main purpose of open circuit test is to estimate iron losses. Iron losses depends on voltage. Generally any machine, the very important point is generally any machine or any device gives best results at low rated value side. So iron losses we are calculating. That's why iron losses depends on voltage. Hence, which side is voltage is less, that side test is conducted. That's why open circuit test is conducted at low voltage winding side by keeping high voltage winding terminals are open circuit. By keeping high voltage winding side terminals as open circuit. See the diagram here. Supply voltage is given, variable voltage we have to give, so auto transformer is connected there, ammeter is connected, voltmeter is connected in parallel to the supply to measure supply voltage. Ammeter is connected to measure supply current, and one wattmeter is connected to measure input power. Here wattmeters are of two types as we discussed. Those are low power factor LPF wattmeters and upper power factor UPF wattmeters. Based on power factor, wattmeters are classified into two types: low power factor wattmeters LPF. Upper power factor, remember UPF means upper power factor, it is not unity. Many students may consider this as unity power factor, is wrong. Upper power factor, to measure power factor more than 0.5 we connect UPF wattmeters. To measure power factor less than 0.5 we measure LPF wattmeters. So all meter devices are connected to low voltage winding side. And here see about wattmeter terminals. I explained MLCV, what is MCLV, main terminal, common terminal, load terminal, voltage terminal. There you are having two coils, current coil and voltage coil. Current coil is like ammeter, means almost zero resistance. Ammeter is having almost inter resistance is almost ideal ammeter, zero resistance. That's why we represent current coil with a single turn. And voltage coil is also called pressure coil, is having more, it acts like voltmeter. That's why it is represented with more number of turns, resistance and some inductance we are going to represented there. So go to wattmeter, small introduction. Now come to open circuit test. And in open circuit test, the wattmeter reading shows input power. That input power represents no load power. That no load power is always constant. It won't depends on load. That no load power is also called iron losses component, iron loss power. So the wattmeter reading is nothing but constant or iron losses. V1 into I naught into cos phi naught is also equal to wattmeter reading. So we know wattmeter reading, we know V1 value, we know I naught value. From this easy to calculate cos phi naught, which is nothing but no load power factor. So if you know no load power factor, we can calculate working component of current and magnetizing component of current. Magnetizing component of current will calculate by using formula as I naught sin phi naught. Working component of current will calculate by using formula as I naught cos phi naught. So Rw, after that we will calculate remaining shunt branch parameters R0 and X0 by using formulas. R0 is equal to V1 by IW, X0 is equal to V1 by IM. This is about open circuit test. Now come to next test, short circuit test. Short circuit means complete load, full current will flows. So for the purpose of this test is here, the purpose of short circuit test is to predetermine or estimate the copper losses. And the second objective is to predetermine the series branch parameters like R01, R02, X01, X02, Z01 and Z02. And the third purpose is to estimate the voltage regulation of a transformer. Remember, if examiner asks you to find a voltage regulation, means we have to use only short circuit test. Why? Because if you see the voltage regulation formula, in that all variables we are getting from short circuit test only. That's why to calculate voltage regulation, only short circuit test is enough. And next is to know the short circuit power factor, cos pi SC. Short circuit power factor also will calculate. Here condition is here copper losses. Now here short circuit test main objective is to find copper losses. Copper losses depends on current. That's why which current. Now that's why here we have to apply rated current. There open circuit test we apply rated voltage. Why? Because we are going to calculating iron losses. That's why we have to apply complete value. That's why here also we have to apply rated current. Now which side we have to test the test? That is main. We have to know the main reason. Which side we have to test? What to discuss? Any machine or any device gives best results at low rated value side. If you see transformer, it transfers always constant apparent power. Apparent power always it transfers. Now if you see voltage ratings, if voltage low voltage side, if voltage is less means that side current is high, because V1 is equal to V2 by 2, V2 by V1 is equal to I1 by 2. Now already transformation ratio also discussed. So which side voltage less means that side current is high, and which side voltage is more means that side current is less. So now we have to apply rated current, that to lesser value. That's why we have to select secondary side. So not secondary side, high voltage winding terminals. So high voltage winding terminals we have to apply a rated current. Here you short circuited their secondary side. So because of a secondary current, irrespective primary side current flowing is also very high. So that's why the windings are designed to work for certain range of currents only. If that much rated voltage, if you applied very high current will flow, because of unnecessary overheat of windings, winding may get damages. That's why we have to apply rated current only at high voltage winding side, means we have to apply reduced voltage with rated frequency. Means here we have to apply rated current at reduced voltage at high voltage winding side of the transformer. High voltage winding side of the transformer. See here all whatever I explained, here I wrote all the points. See the diagram here. So diagram here reduced voltage. Our target is what here? Ammeter. In case of open circuit test, our target is voltmeter, rated voltage. Voltmeter, by seeing voltmeter only we have to apply rated voltage. Mostly we have to apply auto transformer. Why? Because auto transformer gives variable voltage from 0 to rated voltage. That's why input from AC supply across the AC we connect one auto transformer. From that auto transformer we will connect all the devices. Here wattmeter used is UPF wattmeter, upper power factor wattmeter. By keeping low voltage winding terminals as short circuit. See there low voltage winding terminals are specified with less number of turns. See there less number of turns. High voltage with more number of turns, more number of turns, more number of turns. Now here wattmeter reading, Wattmeter reading specifies copper losses. So wattmeter reading defined as V1 I1 cos phi 1 or VSC ISC cos phi SC or ISC square into R01. Total copper losses from primary side is I1 square R01 is also equal to ISC square R01. Wattmeter reading is showing copper losses. Now from voltmeter reading and ammeter reading we can calculate V1 or VSC, I1 or ISC, we can note down. So from that we can calculate cos pi SC. Cos pi SC is by using formula WSC by V1 into I1. Now we can calculate here total impedance of a transformer referred from primary, that is Z1 is equal to Z01 defined with Z01, which is equal to V1 by I1 or VSC by ISC. From that we can get Z01. We know formula for cos phi, power factor, one more formula is cos phi is equal to R by Z from impedance triangle of a transformer. R by Z means R01 by Z01. With that also we can calculate cos phi SC. Because both you can get same values, cos phi SC is equal to WSC by V1 I1 or R01 by Z01. So from this we can calculate, estimate R01. Basic formula is R01 is equal to Z01 into cos pi SC. If no Z01 R01, we can calculate X01. Total equivalent reactance of a transformer referred from primary is X01, which is equal to Z01 square minus R02 square under root. After knowing primary R01, Z01 on primary side, we can calculate secondary side also. By using formula R02 is equal to K square into R01. Here remember K value what you have to take. Don't take transformer rating. K value you have to take as K is always equal to E2 by V1. Here E2 is nothing but what? High voltage terminal, low voltage, low voltage, low by high. Remember very carefully you have to take here K value while solving problems. X01 is equal to K square into X01. So from this we can calculate Z01, Z02 also if we needed. Now take voltage regulation formula. Voltage regulation is equal to I2 R02 cos phi 2 plus or minus I2 X02 sin phi 2 by E2, plus for lagging loads minus for leading loads. If examiner asked to calculate voltage regulation means circuit test data is enough. If examiner asked to estimate efficiency means we have to conduct both the test, means we have to take both the test readings. Now to understand this theoretical concept, let me to solve one problem here. See, one problem is given as a 110 by 220 volts. Here given rating is E1 is 110, E2 is 220. 110 by 220 50 Hz single phase transformer, given the following test results, and the rating is given as 2 kVA. Transformer rating is 2 kVA, and that from open circuit test got the results as 110 0.5 volts 25 watts. Short circuit test result data given as 17 volts 9.09 amps and 110 volts, and 110 volts data is given. And after that exam is asking to calculate, to predetermine no load branch parameters, series branch parameters. After that he asked to estimate efficiency at full load, half full load, 3/4 full load and 1/4 full load at particular power factor is specified as 0.8 power factor. After that he asked to predetermine the voltage regulation by considering at 0.8, 0.6, 0.4, 0.2 both lag and lead conditions. Exam asked to solve. Now if refer the given data if written